for this one. It's a combination of math and physics. Did you know that? Do you know that? Yeah. How's your math?
I think I think it's quite good. Yeah.
It's okay. Oh, good. Okay. Doesn't matter which one we choose. Do you want to choose which year do you want to study? It's
how many do they have? Oh, so many of them.
Yeah. Well, I think don't worry because I think if you can solve 1/3 of the problem, or at least you know how to solve 1/3 of problem, that's okay because this is new for you, right?
Yeah.
Okay. Can we just from natives from number 20 last year?
Okay. Yeah.
And also I think that will be, if you prepare for this year, I think that would be very close, right? Although that I don't think they will repeat the question, but at least the format will be the same, right?
Yeah, and I saw the conditions like they don't allow graphic calculators and formulas.
That's right. No formula. Yes.
I think I might be struggling with like formulas.
That's okay. You see what you do. You take this chance when we solve the problem, and you write down the formula they used. All right. Okay. And based on this material, we can expand that in a little bit. Okay. Probably just at the end, just 2 piece or 3 piece of pages, 2 or 3 pages. All right.
Okay. It has 42 pages.
Oh no, not I'm exaggerated. Okay, if you understand and you know how to derive the formula, you don't have to know that much. Okay, this is first question. Do you want to try?
Yes, it's I think it's
sequences, right?
Yes, geometric.
Yes. So can you see? Can you find that? So basically, what you're looking for the next number. So I think this is a very typical question of this PAE because they want a student to somehow to derive something unknown based on the train, based on the pattern. Okay.
I think I can do that with the formula presented to me, but I just don't remember it.
Do you have can you write? If you can write, you can write from your side.
Okay. I need to check my formula sheets.
Oh, doesn't matter. Yeah. I think you know how to you choose you use annotate to write.
Sorry.
You can annotate. You can write. You can find the view option, so you can write.
Yes, I can write.
Yeah. You have to choose a view option.
Sorry.
If you just move your mouse to the top, and the menu the menu will drop, and one of the option is view option.
View option.
View option. You will see if you I just one moment. So if you will see the view option, you will choose view option. So that option. One of them is called annotate.
Oh, do you want me to write on it? I can write.
Yeah, you can write. Yeah, you can write,
I just don't remember the formula.
Oh yes.
Yeah.
So you guess is geometrical. So the ratio must be the constant, right?
Yeah, times 32.
You can use you can't use calculator.
Yeah. I can use calculator, but not graphics one. It's the
you can use calculator. Yeah, is that you can guess it's either is arithmetical or the geometrical.
Oh, it's not times 32.
It's not multiple. Wow. So you have this so the formula is not as simple, right? So if you divide that, what would be the answer? 32. Oh, it's a fraction, so it's probably not that simple. All right. So this probably is not straightforward, right? You probably will think about it next time, all right? Because given this time, probably basically what is that I write down here. So basically what they are trying to ask you is write the general formula, all right?
Yes.
For example, it could be n could be n plus n squared, such as or multiply 2 or divided by 5, something like that. All right. So you have to guess, trial and error.
Yeah.
You keep try it. Okay. Okay, we'll give up. Give up. Let's go to the next one. Do you want to try or not?
I'm trying it on my calculator now.
Yeah,
but
you're trying. Yeah, yes.
Yeah.
So it seems to be that it's a multiple by 3, right? It's a multiple by 3.
It's not.
Oh, it's not exact by 3. It's
Yeah.
close to 3, right? Or
From the
3.2. Okay.
From the second one to the third one is 7.59.
That's right. That's
Yeah.
7.
And the
So I think the general formula. Well, another thing. Oh, I tell you what. You don't have to go to that. I just realized you don't have to go that accurate. Okay. So this is you just roughly estimate. Okay.
Yeah.
So this can we just rewrite this as 130 roughly? Can say 30, right? And 250, right? You just simplify that and 300. So roughly, what would be this next one will be? Yes. So how many times? I think close to 7. Did you say? But this is 3 times. See, this is 3 times than that, right?
That's 4 times.
This look at it very close, but because my number is not very accurate. 4 times.
It's not really pattern.
No pattern. Yeah, no pattern.
Yeah.
Well, that is so. This, how about this one? This 30, right? That's huge, right?
Yes.
Huge. Well, I think it's not straightforward.
Is it?
Any other way to work it out? I think I think this is a very likely. Number 8, just guess. A is very likely.
Oh.
Because they didn't ask you exact formula, right?
Right.
Can you see that? Because you see,
Yeah.
is that the range of this exception, right? But this range is just about 4 times or 5 times. Okay.
But I think this one's reasonable too, because that's.
Oh yeah, that is not equally. That is equally.
That's time too.
Yeah. No, this is not physics.
Yeah, that's times 2 too.
I just we don't have to spend too much time. We just know there's such question. All right.
Okay.
We're stop guessing. I think we just pick up one we can solve, right? We can solve. Oh, hang on. We have to go to the next one.
Do you know how to solve that one?
The first one?
Yeah.
The first one, yes. I think you have to use a trial and error. Can you see? I probably write the question. I think it's combination of the sum and the square or something. The combination of the, if not the square, but it is not certainly. This is certainly not as arithmetic, right? The increase faster. If you wish, I think let's just spend more time. If you wish. So basically, we just use a graph. Can you use a graph? That's another thing you can use, right? So this is first term is 1. Can you see first one? Oh, hang on, I have to work out this one. Can we say this is 6,000? Okay.
Yeah.
That's what I would guess. This is 3,000, right? 3,000. So 3,000 and 5,000 will be here. Can you see?
Yeah.
5,000. So 5,000, 4,000. You use just this called the extrapolation, right? You just found this, for example, this is 1, this is 2, 3, 4, 5, 6. How many terms we have now?
6.
Yeah.
Just
3, 4, 5, 6. Okay, 6 is unknown, right? So we just use the graphical method. Can we?
Yeah.
So this is 1, 2. That's 2,000. Okay. This is 1,000, right? Roughly. So they Can you put them together? The number 2 is 30. Wow, 30 is very close, very small, right?
Yeah.
30 is very small. When you go to that is 1,000, 1/3. Okay, 1/3 over here.
Okay.
Can you see?
Yep.
And the 4 will be jumped to 1,000. Can you see? This is 1,000. Can you see 1,000 or more, right? What is it? What exact number? You can't see. Let's do it. Let's see. I forgot. I should see.
I think it's 1026.
Okay, just in this way we can see it. Okay.
1024.
So we just use graphical estimate. Okay. So it's 244 is 1,000, near 1,000, right? Can we do that?
Yeah.
How about 5? 5 is 3,001, somewhere here, can you see? Okay. So for the 6, if that is correct, we can rely on this this fitting. Can you see? Imagine use the fitting line here, right? Can you see that?
I can't see anymore.
Can you see my writing? Can you see my drawing?
No, I used to can. I could see before, but not now. Did you close something?
No, I just I want to. Oh, if I stop, I lost everything.
Oh.
Let's just try again. Can you see it? Can you see my writing?
Yeah, I can see your screen, but I can't see your writing. Oh, the writing is back.
Writing is back. Okay, can we try it again? I think the graphical method will help, right?
Yeah.
I annotated that. Yeah, you can draw that. We probably make the make is smaller. So this is 1, 2, 3, 4, 5, 6, 7. Can you see this is 7? Is 1 is 1K. Okay, is multiply 1,000. We just use number. Okay.
Yeah.
Can you use graphical method? 2, 3, 4, 5, 6. So that beginning is almost 0, right? Almost 0.
Yeah.
How about 3? 3 is 200.
Oh.
Yeah. You just redo. You can use the redo or undo. Redo. Okay.
2 is also here.
So 2 is very small.
Yeah.
3 is very tiny. Can you see? This is 1/3. Is 1/3 of that. Very tiny. 4 is what? 4 is 1,000. 4 is 1,000, right? Roughly. 5 is 3,000. So 5 is 1,000. So if I use the proper, if you just use it by hand, are you able to use, or you cannot use graphical calculator, right?
No, I think I know how to do if you use graphical.
If you use your graphical calculator, we should be able to estimate that number.
You can insert 3 points and get the.
You get the fitting. That is you can use a polynomial.
Oh, I think that's up here.
Let's have a look.
8,000.
So this is less than 7. All right. Could be this one. Could be this one. Can you see? Because you see, you have used a straight line. Let's just use a straight line. I have draw the straight line. Can you see? Oh no, I draw this straight. I draw vertical first. So this is the 5th. Hang on. This is 6. Can you see? So 1, 2, and 5, 6. Well, I think it's second now. From now, it looks like second. Can you see? This is 6. Sorry, this should be 6.
Yeah.
Well, that's my trial. Okay. Because they encourage you to estimate sometime. For example, if we have no formula, we just found the trend line.
Yeah, I think this one is very difficult to find because it's.
Well, you see, when you solve the problem, there are 2 methods. One is analytical, which means you have to find the formula, or another is a graphical. So what I use is just a graphic. I
think graphical is a better method because I think the function may be like e to the power of something.
It could be exponential. It could be exponential, right? Yeah. Okay.
Does it have answers to the paper?
No answer. This paper have no answer. Don't worry about that. The important thing is, you see, this is the first time, or this is the first question, okay? Don't try to be perfect at the beginning. This is just like learn how to draw. Do you know how to draw? The pen, okay? You cannot draw the full portrait on your first trial, right?
Okay.
You have repeatedly draw this approach because we got 3 months or 4 months, right?
Yeah.
Okay, that's enough for this approach, all right?
Mhm.
Unless one day you came out with some new idea, okay?
Okay. So do you think it's C or D?
Well, I think we can categorically exclude this one. We can categorically exclude this one. The only thing is we depend on how confident of this drawing.
Yeah.
Maybe next time you will use this tool to draw a perfect straight line and perfect interval. Can you see?
Yeah.
You can have a ruler. Okay, you carry a ruler. You say the inch interval is exactly 2 centimeters, right?
Yeah.
And you can draw the parallel line that will allow you to draw these 5 points exactly.
Okay.
Then you can more confidently to get that the next value. All right.
I think I learned how to do this like by graphical method because I used to don't know.
Okay. Well, that in physics sometimes we have to use graphical method.
I learned something today.
Okay. It's how can I will stop and go back. Don't worry, you will encounter different question. All right. This is a different setup. This is about the spring. So we have just reviewed the spring, right? So what is the question? I probably will reduce the size a little bit. Okay, we can see the whole question. Can you read the question? What is the question?
The effective string constant K.
Yeah.
In this diagram.
Yeah, so we need to find the effective. So basically this, I just annotated it from my side. So this time, we are looking for the what we call the effective, because there's more than one spring, can you see? Okay, so how do when we solve the problem, can we just use a letter to represent? Can we use KE, right?
Yeah.
E for effective. And each of these 5 spring has the same spring constant. So what would be the effective? Which one would be the correct one?
I think it's.
Do you guess? Or is 1/3? You think?
That's 1/2.
Half.
And they add together will be like
That's a good idea.
Yeah.
Which one? C? You get to C?
5, 6K.
5, 6. Wow.
8.
Yes. But this is how do you justify your method?
I think the constant will cancel out if they are like parallel. Well,
you have to so that's right. There are 2 things. Can we start? We spend more time. Can we start from simple one? Can we just study the 2? Can you see? Can we just study 2 in series? Okay. And again, this is identical. How can we work out these 2 constant? These are effective in this case. So by definition, we have to work out the force acting on each spring.
Yes.
According to the knowledge, no matter whether you, or by the way, this spring has no mass. Okay.
I think it's the same.
The same. Can you see at each point, the force is the same, right? And so then you can use the you can apply when we study the mechanics, we have to isolate object, right? So this object, if this mass is m, so the gravity is mg.
Yes.
Right? So because it's not moving, so therefore the tension will be equal to mg. Can you see?
Yeah.
T minus mg must equal to 0. Because why? Because the acceleration equal to 0. Can you see? So that is Newton's law. Okay. So everywhere the force is T. Okay. So then you can assume that for the first spring, the displacement is delta x. You see?
Yes.
And so does the same one, because these are identical same force. So this displacement must be identical. Displacement must be identical. Okay. So what you can write is that T is actually, in this case, T is equal to the inelastic force. So according to Hooke's law, that K, the force in this case is a T, right? The tension, but equal to because no matter where you go, the force will be the same. So this will be T will equal to K multiplied delta X. This is Hooke's law. Okay.
Would it be 2x if that's the displacement?
We can assume these displacements are identical because the force is the same. But yeah, as a whole, so what we're trying to do, we need to find the effective single spring. You see, the single spring whose constant is Ke, right?
Yes.
Now, if we just use the Ke, and we will have because in this case the total displacement will be double. Can you see? So if you use a Ke, that tension will equal to Ke multiply 2 times delta X.
Oh.
Because you see, this is the total displacement is 2 delta X. Can you see? Okay, so if substitute this formula here, if you combine the two formula here, T is equal to mg, right? So they got mg Ke. That will be equal to that will be equal to mg Ke multiply 2 delta X. Can you see? 2 delta X. All right. Are you convinced? That's 2 delta X. Because each spring contribute to the same displacement because they are identical.
Yeah, I have a question. I'll draw it on the screen. So
you can draw.
Oh, wrong. It should be a spring. Just assume this displacement equals to 10 meters. So it's stretched for like 10 meters.
Do you mean the change is 10 meters?
Yeah, the change in
oh, that's too big. The too large. Probably just
for example.
Yeah. Okay, for example. Like for 1 centimeter would be fine. 1 centimeter.
If they combine together, would this still be like 10 meters?
No, because this is the same. You can focus on. You can make the force. You can measure the force at different. As I just indicated that, you can measure the force at different position. Can you see?
Okay.
Because we can argue at each of these position, we can always apply this formula. Can you see? In other words, the tension at these 3 points are identical. Do you agree?
Yes.
Yes. If so, therefore, the force acting on the first spring will be equal to will have such displacement.
Yes. So what I draw on the right is correct.
Yes. That's right. That you just double. If you put it in series, it's just double the displacement. Okay.
Yeah.
Can you find the solution now? So we have 2 equations now. We have this this simple single equation. We got this this is actually 3 equations. Okay. Can we solve this puzzle by these 3 equations now?
Yes, I think the springs in series will stay the same.
Do you mean do you mean effective spring will be the same?
Yes, I think it will be 2K.
It will be 2K or half K?
2K effective in total.
Well, let's just solve this puzzle. Can you see? Okay. So from this is question 1. This is question 2. This is question 3. Okay. So from equation 3, we have from equation if we just substitute that one, if we just do substitution, if we just substitute equation 1 into It's a very simple algebra, right? Into 2. So we got mgk. mg will equal to k delta x, right? And then from here, we can see that the so this is so we can solve. So this is given. So at delta x equals delta g, but from equation 3, what we can have? We can have. Can we divide it by 2? Okay. This is sorry. This is ke now. Can you see? It's ke. From equation 2, we have that mg equal to 2 delta x k, right? Ke multiply 2x, 2 delta x, right?
Yeah.
So how can we replace this? Because this is t, so this is also the same. Can you see? This is also mg is also equal to the. On the other hand,
K delta x equals to effective competence times.
Yeah, so the single delta x, I'm just equalizing. Can you see? This is probably the quicker way. Ke multiply 2 delta x. Can you see that?
Yes.
From here, what is the ke?
Ke equals to k.
No.
Oh,
it's a
2ke equals k.
No, to half.
Huh? Yeah, 2ke equals k.
So you have to use formula. You cannot guess. All right. So that is they just save this in case we're cleaning up this. So that is a simple scenario when the two in series. Okay. So and then next, because this is part of our learning. Okay. So we don't have to solve it so quickly. I will clean that. Then we'll go to the parallel configuration. Okay. Okay.
Okay. Can I try?
You can try this time. So this time we consider the two parallel. So this time we in parallel to two identical spring in parallel. Can you see?
Yes.
I put the weight here. Is mg. Do you want to try?
Yeah. So this one will be delta x.
Yeah.
Delta x.
Okay.
So.
But this time, be careful. This time, be careful. How about this force at these 2 points?
They are halved.
Half of weight, right?
Yes.
Half of the weight. Okay. Can you write it down? Can you write? So basically, you can, if you use, can you get used to this? To draw this free body diagram. So this mg, can you see? That is a t. This is a t. Can you see? This is t. Can you put this is a t? But this t and this t is different. It's a t1 and a t2. Can you see?
Yes.
T1 and T2, they have a simple relation. Can you see? So T is equal to T1 plus T2. Do you agree?
Yes.
Yeah. Okay. So this is our first equation, and they all equal to mg. That's equal to first mg. Okay. How did you get this one?
Because mg equals t.
And is this k is effective or not?
No.
So you have to assume what is so basically our objective is to work out the single spring, okay?
Yeah.
And whose inelastic constant is ke.
Yeah.
So in this question, is this k or this is just k, right? It's just the k. That's right. Yeah, that is k. Okay. How can we build the equation for ek? This is our first equation. This is our second equation.
I think for ke, mg will be like mg. The tension force equals to mg.
Yes, that's right. So
equal to...
you don't have to think. You can draw the free body diagram. Can you see? So this is a free body diagram that allows you to make the conclusion. This will be ke multiplied delta x. Can you see?
And the displacement will just be delta x because it's not doubled.
In this case,
Yeah.
it's the same. Yes, it's the same.
Oh, I see. I got it.
Okay. So
Yeah.
what is KE this time?
This time equals 2k delta x equals to ke delta x.
Yes.
So
it's doubled. See, K is
Yeah.
double. Yeah.
yes, when you cancel out this two, it'll be like
Okay.
2k equals to ke. Yeah.
Yeah. Now you another thing you need to learn is how to generalize this method. Okay.
Mhm.
For example, before we touch this question, can we just generalize that? For example, you have the n, you have n's more than one. These have n spring. Can you see? And put the weight here. So 1, 2 until n, and each they are all identical massless spring. In this case, what is effective constant as inertial constant?
nk.
Yes, all right.
Yeah.
Can you see? You can generalize, okay? And also for the spring, you can also generalize this one. If you have 1, 2, and more than 1, can you see? And this is finally got the weight here. Is 1, 2, n. So what is effective inertial constant in this case?
A over n.
Yes, right. Can you see? So when you study physics, you have to learn how to use a generalization. All right. Now you should be able to solve this original question.
So the first one.
This question is different now. This question is the first effective is different. Can you see? From these two. So you got in spring, but these two are not identical. Can you see? That's right. So one is 2K, one is 3K. Now, according to our series connection, so what would be the effective one? Oh, hang on. When spring, yeah, that's right. It's just multiply. Oh, that's right. Okay. Yeah, that's right. So how can we put them together? They are in series now, and they are not identical. So this formula, we cannot use this formula. They are not identical, right?
Yes.
This formula can only use for the identical spring. If they are not identical, what can we do?
Do you go back to the?
Yeah, we have to redo that. Use the same strategy for the parallel for this series. Can you see?
Yes.
But in this case, and we have the. Can we do that? Can we just consider this simple case? Can we just consider this simple case? We have two spring whose inelastic constants are not the same. So how can we find the effective one? Can we just use the same strategy because the delta x must be the same? Do you agree?
Yes, that's what I was thinking.
Okay.
So it'll be like mg is also the same.
Mg is the same. The gravity is the same.
A1.
Current delta x, right?
Mg equals 3k delta x.
Okay.
K2 g equals 2k delta x.
Okay.
When mg is the same, do you equal them together?
Yeah, you can equal them. Yeah. But it doesn't. Okay, we have trouble.
Doesn't work.
Yes. So maybe this is not a straightforward question. Let me see if this mg. Probably the displacement will be different this time. Can you see? Oh yes, the displacement will be different, of course, because the spring constant change. So we have to specify delta x1. Can you see? Delta x1, or can we just call the can we just x1? It's a displacement, right?
Yeah.
And this is x2. How about effective one?
Oh, right. This is what we are not over. But yeah, we can't solve that.
We can. Can we just this was first spring, this for second spring. The last one, we just use the force is the same, but the displacement would be the sum of these two. Like I give you one more equation, can you see? That is x1 plus x2. Do you agree?
Yes.
This is x2.
But you don't know the displacement though.
Well, the displacement, it doesn't matter. We can solve that.
Oh.
We can solve that. We can solve that. Three equations. Can you use this corner? We have three equations. How can we solve this puzzle by using these three equations? What is x? Is it x1?
Yeah.
How come? Can you explain?
From here.
Can we just solve the x1, x2 and substitute in equation 3?
But you can't solve it.
Or x1, we can solve the x, can we?
You can't.
Can we x1? Can we solve? I show you how to solve the x1. X1 is mg over 3k.
Yeah.
Can you see that? X2, you just solve second equation. That is mg over 2k. Can you see?
Yeah.
If substitute that into this equation, we got ke. Can we solve the ke? That is mg divided by x1 plus x2. Do you agree? Okay, you just need a bit of algebra now. Can you use your mathematical knowledge to substitute these two x1 can we use this formula to replace this x1 and x2?
Oh, I see. So you just.
I think this question is very interesting, right? It's very interesting. It's challenging, but it's interesting.
You just eliminate x1 and x2 in the substitution.
Yeah. Can we give you some space? Can we just can you use this? Can you use this corner to solve this puzzle? Can you use this corner? If your algebra is good, and then you can solve a lot of the question in physics. Once you got to the formula, okay.
I think the logic is the hardest part. The logic.
Mathematical. You are talking about mathematical problem.
No, like physics. You get the logic behind.
Well, formula. No, physics is not logic. Physics is logical unless you know the formula, right? If you want to solve the physics, you have to really understand the idea and the formula in physics. Of course, mathematics is logic. You see, mathematics is logic. Can we eliminate this mg?
But we need to like add the fractions together though.
Oh, this is a simple fraction. Yes, so we can actually, if your algebra is good, we can cross this. Can you see? We divided mg. That becomes one.
Doesn't work.
Yeah.
Doesn't work that way.
Of course, if you can we just talk about the fraction? See, if you have a divided with a and b.
Yeah,
you see,
you're right. You're
plus
right.
A and c. Can you see?
I'm being dumb.
No. This is just warm-up process. All right. This is just first time we just see the real question.
So it will be like 3k plus 2k, 5k.
No, you're oversimplifying. How do we put the fraction together?
So dumb.
So from the common denominator, right? You have to count.
Yes, that's right. Equals to 6k over 5.
Yes, although we don't have standard answer, I'm sure this is the right way to go, and hence the answer
Yeah.
should be correct. Can you see?
Uh-huh.
So don't guess. All right. You only guess
Yeah.
until we have no idea at all.
Yes.
That
yes.
just remind you that could happen. All right. During examination, that could happen. So we save this page.
Oh, this is so much more complex than I would have thought.
Well, I think it's different though. It's different, right? I just I save that, and also we got a copy. Clear draw. Okay, let's go to the next one. Mathematics again. Oh, that is the formula. That is sequences again. So we got a 10 terms, right? And what would be evaluate the sum. So you need to find this, or you need to work out the sum.
I already forgot what that notation means. I think I
sigma. This is called a sigma notation.
Yeah, I know that, but I don't know what it means.
I show you. So sigma.
The
sigma notation is this thing. See, if you have the sum of the un, right, and n from 1 to 2, that will just simply written as u1 plus u2. That's all. Can you see?
So
that's called sigma. This sigma means the sum. So sigma means the sum.
Is it n plus 2 minus?
Wow, it takes ages. You want to do it one by one?
No, I'm just using it.
The formula. Do you know the formula for the arithmetical and? Do you know the formula of the arithmetical sum and arithmetic sum for the arithmetic? Where is my formula? Where is my formula?
Is this how the notation means? What I written there?
When n equal to 1, that is yes, that's right. Until 10, yeah. Yes, that's right. That's your.
I go back.
Yeah, you pick up, right? Yes, probably you learned it some time ago, but you forgot. I think. Now, it's not straightforward. If you just do this 10 times, take probably your half hour, 10 minutes. Okay, you have no time to do other things. But to remind you, do you know the sum of arithmetical sequences? So what is the arithmetical sequence formula? Do you remember?
No, I don't. It's on our formula sheet.
That is that have several forms, and the sum can be written as this one. That is n divided by 2, the first term plus the last term. Or in other words, in our case, in this case, n equal to 1 is equal to 10. And the u1, you need to find what u1, you see?
Yes.
So that is the sum. Or another formula for the geometrical sequence I write down here is equal to this. That is 1 take r. Do you know this formula? u1, 1 take
I think that
r
one's
to
what
the
I
n.
learned from school. Yeah.
Yeah. So these two formula are very important. So if you want to memorize the formula, you can memorize this formula. Okay, there's two.
How do we recognize that's arithmetic? Because it's a sum.
No, it's a mix. This is a mix, not this. That is not pure. It's a mixture.
Oh.
Have you tried? Have you solved this type of question before?
I don't remember.
Now,
arithmetic is in unit 1.
Yeah, can we just do this one? I just forget. It is 2. This original sum. Can you see? n2 plus n to power n. Can you see? Yeah. Of course, you can add the 10 term together. However, can we also use this one? So basically, the first is constant, right?
Yeah.
First is just constant. The second will be put as a half outside. Will be the sigma n. Can you see? The third one will be sigma 2 to power n. Now this time I just added n here. So this is so basically this n. I use n then. n equal to 1 to 10, okay?
Yeah.
1 to 10, and this is the same. Just copy the formula, can you see? And from this is called the from 1 to 10. Okay, tell me, can you say sequence both? How many sequence? How many geometrical sequences can you see?
2.
Which one is geometrical sequences?
The second is the third.
So this is a geometric. Do you agree?
Yes.
And this, how about this one? How about this one? How this is this if you just expand that, that's just 1 plus 2 plus 3 plus until 10. Can you see?
Yes, that's arithmetic.
Arithmetic. So
Yeah.
the difference is 1, do you agree? Or the first, this is our U1, can you see?
Yeah.
This is our U10. Can we use this formula very quickly? This formula. What's the purple one?
Equals 10.
Divided by 2, yeah.
Can't write it. It's over 2.
I think so. Yeah, I think so. That's right.
Yeah, I can't write it. I don't know
Yeah,
why.
so that is 11, right? Is it 11, right? It's 11.
Yes.
11 multiplied by 10, 25. Yeah. Ultimately, we have to, yeah, that we have to think if this is good direction to go, because that can quickly, how can we focus, before we go, can we just work out this sum first? How about second one? Using the arithmetical, geometrical sequences formula. Can you work out this sum?
R equals to.
The ratio is 1. Oh, we cannot use this one.
The
ratio is 1. How can we solve this one?
What's R? R is
the ratios, yeah, the common ratio.
Yeah, but it's exponential.
Yes, that is something unusual. So this is this sequence is can we treat it as geometrical? Think it again. If so, can we just write the sequences? That is 1. Oh, so the one. So first is 2, right? Second is 4, and the next time is 8, right? This formula cannot apply for this particular. Oh, ratio is 2. Sorry, not 1. It's 2. It's 2. Sorry. R is.
But it has a ratio.
So the ratio, can you see this is the ratio? So this U1, the first term, the second term, can you see? The third term. So if you use the U2 divided by U1, equal to what? Equal to 2. Do you agree?
It has a ratio. Yeah.
Yeah, the ratio is 2, not 1. I'm surprised. Yeah. So that's a huge case. That's the way you check if this sequence is geometrical.
What's 2 to the power of 10?
Do you for this one? 2 to the power, that doesn't matter. We can keep that. We can keep that. We don't solve this. We just keep that. We got this term there, so that's good. Okay. So the last term is 2 to the power of 10. We just keep that. Oh, this is 11 by 14 divided by 4.
Let's see.
Yeah, we need to combine this. Finally, we need to combine the first 2 terms. All right.
Yes, you should add them together.
Yes.
So you'll be like 2 to the 10 minus 1. Okay. So the whole thing will be 2 minus 50 over 52 over 2
Yeah.
plus 2 to the power of 10 minus 1.
Okay, can we simplify these two numbers?
Hmm.
We just keep the 10 to the power 10. Okay. How about work out these three numbers? 2 minus 1 is 1. Can you see? 2 minus 1 is just 1.
Yeah. What's 1 minus 55 over 2?
Yeah.
Equal to, I think match none of the answers.
We have to be careful. Yeah, because I'm confident we are the correct. Did you work out this? So this is the first term. How can you get this term here? Negative. We got a positive here. Do you agree?
Yeah, that's an equal sign.
Equal sign. Okay.
Yeah.
Okay. Can we work out this fraction? This is different.
Yeah. It's
negative number, right?
53 over 2. That's one.
53. Well, none of them.
Yeah.
Maybe we miss out something. Did you divide this by 2? Did we? We have to divide this by 2.
Yes.
No, we didn't. Oh, you divide. Oh, you did.
I did it here.
Yeah, by 2. You did by 2. Oh well.
Yeah.
What a pity. We nearly, but it's as far as the time spent concerned. So this is much faster, right?
Okay.
How
many questions does it have on the paper? Can I check?
Hang on.
Okay.
If you the first about 20 about under 30, 25 or so, 20 some. 25.
That's good. That's good.
Yeah. All right, we were thinking about next question. Basically, this is the right way to go. All right.
Oh.
Maybe there's misprint, so don't spend too much time to compare with standard answer. Okay.
Okay.
Because it's when you prepare the exam, you have to know the correct method first. Okay, and also trust yourself. You should get the number correct. Okay, of course, if number is wrong, this still give you 80%. Okay, up to 80% mark.
Yeah, it'll give me 50% because
at least 50. Because for mathematics is 50, but for physics is over 50. All right.
Okay.
Okay, it's trivial. Okay, maybe there's a misprint. Who knows? Okay, this is human error. Okay, what we can save that clear. Okay,
I think what I struggle most is remembering all the formulas. It's so
much.
No,
not easy. At your age, I can memorize hundreds of formulas.
Do you study in China?
No. I studied. Oh yeah. No.
Yeah.
No. I was after graduate university. I was preparing for the exam for the US the PhD students scholarship. You know the Li Zhendao. It's called Caspia. You know the Caspia exam?
No.
That's just for
American University.
This select student from China, but that's a long time ago. But I can tell you, if you use them all the time, you should be all right. Okay.
Okay. I just need to practice more.
Need to practice more.
Yeah.
One moment. Something wrong with. Oh, I have to stop that and go back again. Yeah, as I said, for the first time, if you know how to solve 1/3 of them, it would be good. This is a nuclear. It looks a nuclear. Yeah, it's
That's
nuclear. Yeah.
5 different ions are accelerated from rest by the same potential difference.
Okay.
Which will have the smallest, the mass.
Yeah, the mass. You have to identify the mass and the charge in this case. You want to try?
Potential difference. That's
do you know the notation of this kind? So in nuclear and in atomical or even chemistry, in nuclear physics, we denote any element, atom or nuclear, by their mass number and atomic number. Can you see?
The A is the atomic mass and the Z is the number of
proton and electron. Number of proton or number of charge. Number of electrons.
Yeah, number of proton. The Z is proton.
So basically A, I just give you summary, A equal to number of proton, okay, and plus number of neutron.
Yeah.
Okay. And the Z, then A, Z is also equal to number of proton, this is equal to R, they're just the same.
Yeah.
Number of proton and also equal to number of electron.
Not necessary.
Z,
with
Z number.
Yeah.
If it's for atom, yeah, this is for atom, but for ion it's different.
Yeah.
So this is only for atom, okay? It's neutral.
Yes.
It was atom, but in this table we got ion.
Yeah, I know that one.
Okay. Okay, can you try to solve that? Do you know? Do you what is the potential difference?
Voltage.
It's voltage. So this is. Do you remember we discussed capacitor, the parallel plate? If you put the two parallel plate and left the hole there, okay.
Yes.
So then we can use this as accelerator. Can you see? So the charge for any charged particle with mass, can you see mass and Q, and we can use this device to build the potential difference between these two. Okay, if the polarity, if the direction is correct, the object these can all of them are positive. Can you see? Good, there's a positive. So in that case, if can you draw the diagram? This is something extra. If we want to build a simple accelerator, how do we connect with battery? Are you sure? It's positive. It's positive ion.
Yeah, you
no, it's
from
backward.
positive to negative.
You're backward. Oh yes, that's right. Oh yes, you're right. You are right. Oh, you're right. Sorry.
Yeah. I'm so confident.
Yeah, good. Okay, very good. Okay,
This is
that is the simplest accelerator.
Yeah.
Right, and also that is also the capacitor. If you wish, when we study the circuit, that is also the capacitor. Okay. All right. So do you know the formula for the energy change? Or do you know the formula for work done? So what is the work done by the electric field on the charge? Do you know the formula?
Why are you looking for work done though?
Well, work done were equal to the change in the kinetic energy this time. You see, that is why we need to work out work done. So another keyword, don't forget. So next time you can find this keyword. This is called the rest. When we say or initially rest, we mean this formula can be simply written as EK. Can you see? It can be simply as EK. Because initial velocity equals 0. Can you see?
Yeah.
That is why we need to find the work done. Because this EK, what is EK? Do you know the formula for EK? Kinetic energy.
Don't remember. Half of something.
Half multiplied mass. Yeah, it's proportional to mass. Yes, half mass and velocity is velocity square.
Oh.
These are the basic formula. Okay.
So EK is proportional to velocity.
Because this time they are trying to compare the velocity. Can you see the final velocity? One moment.
Yeah, so you only need to find EK in this case.
Yeah, this is the final velocity. So therefore, we are looking for this final velocity.
Oh, but it's also associated with mass.
Oh yes, you have to consider the mass.
Yeah.
So they are compare which would be smallest. They found the minimum velocity.
Yeah. So we only need this.
You still need one more equation. Think about it. What equation? So what is the equation that built the work and the voltage? Do you know that formula?
Don't remember.
I gave you, yeah. Perhaps I will just show you from scratch. Okay, next time you will learn how to do. So if we just consider this is a capacitor, right? If this is a capacitor, then this is driven by the same setup as yours. Can you see? So obviously there were generated electrical field. Can you see? Electric field from positive to negative. It's called electric field, uniform between the gap. Okay, so this red color arrow represent the electric field. Can you see?
Yeah.
And the voltage is also between these two. So this is the voltage voltage positive and voltage negative. Can you see?
Mm-hmm.
See, this is the voltage of battery. So basically the potential difference. So voltage is equal to the positive potential, take the negative potential, all right?
Yeah.
Another equation is that the relation between the potential, the electrical field is equal to V divided by the distance. This is the distance between these two, can you see?
Oh, yeah.
Okay, so a third equation is a force. The force acting on this charge, can you see? Can we use F?
Mm.
This is Q. Can be simply written as Q multiply E. Have you studied this formula?
Yes.
Okay. Okay, finally, what is, by definition, what is work? So we move this charge from one side to another, so the displacement will be D. The force multiplies the displacement will be the work done. Do you know this formula?
Don't remember.
Okay, well, probably
Yeah.
we have to balance our study. In general, the work is equal to the dot product of the displacement. Can you see?
Yeah.
Then, in other words, that were equal to F multiply D. I don't want to use D because D is used for the differentiation. So I use something else.
X.
Yes, it is S. Yeah, we use X. Yeah. So there's X. We could use. So there's X. Can we use this color? Can we use delta R? Okay.
Yeah.
So delta R is a vector. So the work of general formula can be written as this. That's a cosine theta. So this is the dot product of the two vectors. Can you see? This is delta R and this is F. Can you see that? So this is general formula. Now, if the F is not a constant, you have to prepare to learn this formula. So that is F dr, R from R1 to R2, can you see? And multiply cosine theta. So
the force and distance go in the same direction.
Well, they're not necessary. Yeah, the force and this not necessary. For example, if you apply the force in a different direction other than the displacement, all right?
Oh, I mean for the parallel plates.
Yeah, for parallel plates, theta is 0.
Oh.
So what would happen if theta equal to 0?
Equals 1.
It just equal to R mod F mac R. Can you see?
Yeah.
It's here, right? So therefore, in our case, work done were equal to the force. So what is F? Which is QE. Can you see? QE multiplies the distance is D. Can you see?
Which is.
So what is ED? Is V, right?
V over E.
V is equal to ED. Can you see?
Yeah. Oh, that's voltage.
Okay, so finally we got the new formula for work done is just equal to QV. Can you see?
Yes.
So to solve this question, we need a third formula, that is a QV equal to work.
Yes.
Okay, can you try to solve which one would be can you work out the formula for velocity first from these three equations?
Yeah. Oh, do you just rearrange this one?
You arrange to solve the for velocity. KE? Do you mean the
EK?
K for what?
EK.
Oh, the connector energy, right?
Roll it backwards. Yeah.
Okay, what is EK according to this equation? EK equal to W, W equal to QV. Yes. From the first equation, W equal to EK, okay?
Yeah, I missed. I misread the EK by like the E, the
Oh,
energy.
this is electricity. Is electric field. EK is energy. Yeah,
That's
it's different.
is that the energy unit for electric field? E.
Which one?
E. This one.
No. No. E is electrical field. E for electrical field strength.
Is it the strength? Oh yeah, the
It's
strength.
strength. Electrical field strength. Electric field strength. Yes.
Write down equals Q B.
Yeah. Strength. So what is formula for velocity? So that is formula. Yeah, you found it. Okay, you can then you just in order to find the minimum velocity, how can we choose? How can we choose the proper mass as voltage is the same? You see. So how can we work out the minimum velocity? Mean MIM is for minimum. This formula.
The one which has the.
We have the Q minimum as well. Can you see? Can we write down here? Minimum and M maximum. Can you see that?
Yes.
Now you just choose. You just choose which one. Which one has the largest minimum charge?
Lithium.
A and B, two in the isotope, right?
B.
How about the mass? B. Yeah, B has a max.
Yeah, larger.
Yeah, larger one. Okay, that's
so we just choose from this one and.
Yeah. That's all. That's all.
And
that's all. That's only one answer. One answer.
But this one has larger mass though.
Sorry, but the chart. Oh, you have. Yeah,
has large mass.
Oh, that's a bit tricky. Yes.
Yeah.
They much heavier. That's heavier. That is a 9. But you have to compare these two charts.
We can do this. We can do this by like equaling them together.
Yeah.
Can we?
Sorry.
Can we do this like by?
It doesn't matter. That you can solve by yourself. Basically, we have found the right formula, right? And you have to trial and error to select which one. Okay. So because the charge is just the multiple of electron, right? So you have to basically consider this charge. It's called the charge to mass ratio. You have to work out this ratio.
Remember the.
Sorry.
Do we need to remember the elementary charge?
No. You from this one we can not just. Sorry, this is not the right way to write. We will need this. We need this. We need to find this ratio minimum.
Yeah.
How do we can use maximum mass? We can use you just compare with that. You see that is because they are all Q is a multiple. It's multiple of E, right?
Yes.
And the mass is a multiple of the unit. Okay, the mass unit. Can you see that is A? Can you see?
Yeah.
So therefore, we need only ultimately we only need to compare the N and A, all right, to see which is the minimum. Can you follow me?
Yeah.
So this charge is 3 over 9. So you just compare with 3 over 9, and there's a 2 over 7.
Oh.
So which is larger?
Yeah.
You see? You calculate. You can use calculator, right?
B is larger.
Okay, it's good. Okay.
Does that mean it has larger velocity? So
no. Forget about my first writing, because velocity or velocity square is proportional to this ratio. Can you see? So we only need to find the ratio, the minimum ratio of the Q over mass M.
Yeah, so D has the minimum ratio, so D will be.
That's D correct. D is correct.
Yeah. Oh, got it.
All right, we have solved 4 questions now. That's good.
Yes.
Okay, I will stop that. I will save that.
Mhm.
What do you think? I think that this is a real exam. This happened last year, so
I think it's really effective
I
learning.
think the level of challenge will be similar this year. All right, but
Yeah.
the way they ask will be different.
I think they're not like horrible, but yeah, I feel like
well, you will see. This is just beginning. Some are not horrible but tedious. Okay, I call it tedious. Tedious is they ask not just 2 questions. They ask 5 questions or ask 10 questions.
Okay.
It could be very tedious. So be prepared.
Okay.
Okay.
Well, we'll have that in next session.